alpha, call this phi. Okay, so I'm going to break B2 into its component and B1 into its components and add their x and y components. B total x equals B2 times cosine alpha, right, this component, and then minus B1 cosine of phi, because the B1's x component is negative that way, right? So it's very important, draw a nice picture so that you could break it down and see the geometry. If this is alpha, then this one is 90 minus alpha, and then this one is alpha. So you're going to have to relate that alpha to this alpha so that you can do the little triangle here, right? Because when you do cosine alpha of alpha, how do you know what it's going to be? You're going to have to do it from this triangle. And then if this is phi, this is 90 minus phi, and then that would make this triangle, right? So if that's phi, this is 90 minus phi, and this is phi. Right? Phi, 90 minus phi, and phi. So that's triangle. So I'm going to deal with this triangle and this triangle. So B total x is going to be B2, we can use Ampere's law, mu 0 I2 over 2 pi times R2, right? Mu 0 I over 2 pi R, I'm doing, times cosine alpha, let's just rewrite it for now, mu 0 I1 over 2 pi R1 cosine of phi. Okay. You know what? I'm going to factor out mu 0 over 2 pi because it just keeps reoccurring. So I2 is what? I2 is, that's the 0.8 amps over R2 divided by R2 is going to be what? R2 is this distance. So what's the point? 3, 4, right? The point is 3 from here, from the origin. 3, 4. So this distance is 4 right here. You know what? Let me erase the 90 minus alpha. This distance is 4. And then what's this distance? That original point was 3, 4, right? This point. So the vertical distance of the triangle is 4. The horizontal distance is 3 minus 2, which is 1. Right? So from that triangle now you could say R2 is a square root of 16 plus 1. So R2 is a square root of 17. Okay? So it's very important. Draw it very nice. And then get your triangles. And then after that, it's easy. And then cosine alpha is 4 over R2. So cosine alpha is 4 over R2, which is another one of these, square root of 17. Okay? Minus, and then mu 0 to pi, I factored it out. I1 is 1.2. R1, so again, let's get this triangle. This is 4. And then what's this distance? So the point is 3, right? 3 from the origin. And then this point is negative 3. So that'd be 3 and negative 3, so that's 6, right? This is 6. So this is R1. So you're going to have R1 is square root of what? 36 plus 16, right? Square root of 52, right? So 1.2 over square root of 52 times cosine of phi and cosine of phi is 4 over that as well. Okay? Notice how their x components are competing against each other. As in the picture you see, their x components are competing. It's possible that their x components can cancel. And so here you're going to have mu 0 is 4 pi times 10 to the minus 7 over 2 pi. And you're going to have 4 times, that's 3.2 over 17 minus 4.8 over 52. Oh, okay, so it depends here which one wins. And then here, you're just going to have 2 so depends, this one might win because 17 is a smaller number than 52. So do that. Tell me what you get. And then we'll do the y component. Okay, anyone? Or you could say 19.2 nanoteslas. Okay, so the positive, the component 1, right? Now the y component, B total y is equal to, now what I'm going to do is say B1 sine of phi minus B2 sine of alpha, because the B1 sine of phi is positive, and then the B2 sine of alpha is negative. So again, I factor out mu 0 over 4 pi. And then I have the current of this. So I could do a little bit quicker now because I1 over R1. So the current of this one is 1.2 over R1, which is square root of 52, times sine of alpha phi, which is 6 over square root of 52, minus B2 is equal to 0.8 over square root of 17 times sine of alpha, which is, this one is 1. Seven 7.2 over 52 minus 0.8 over 17. Again, those are competing. So it looks like the positive is going to win again. 1.8.